हॅलो, ऐकू येते सगळ्यांना?
Yes, sir.
Yes, sir.
ओके. So where we are in previous lecture, I think we have how much points we have covered? So from second chapter we have covered construction and operations performing on the lathe machine, then construction and different types of holes created by drilling machine. Then in joining process we have seen manual metal arc welding. Then we have seen gas welding. Am I correct?
No, sir.
And whether we have covered this resistance welding, spot welding, seam welding?
No, sir.
No,
Okay.
sir.
No, sir.
So we are at the resistance welding. 1 second.
सर लास्ट लेक्चरला ड्रिलिंग मशीन पर्यंत झाले.
हो
Drill-
सर.
ड्रिलिंग
Drilling
मशीन पर्यंत
machine.
झालंय.
हो सर.
Yes,
त्या
sir.
फक्त
हा, sir.
diagram
Drilling
काढलेत,
machine
sir.
मशीन वर्किंगचा व्हिडिओ वगैरे दाखवलेला.
ओके,
Drilling
वेल्डिंग
tapping
वेल्डिंग
चा
झालेलं नाही का?
No,
No,
sir.
sir. काहीच नाही झालं.
ओके, ठीक आहे. So we are here then. Joining processes. Okay. Okay. Now in joining processes we will see joining process now here. So there are two types of the joining process. First one is the permanent joining process and second one is the temporary joining process. Permanent joining process it means we cannot disassemble the parts as it is, and in temporary joining process we can dismantle these parts as it is. Suppose this is one plate. Okay, and this one is another plate. Here one more plate, if I add metal plate. Okay, now if I weld here with the welding machine at this point, if I weld, this one is plate number 1, this one is plate number 2, and this one is plate number 3. And here I make arrangement that I drill one hole, and in that hole if I use nut and bolt arrangement. Okay, so it means that I have joined plate 1 to plate 2, and that plate 2 joined with plate 3. So here what is the difference between these two joining processes? This one is one process of joining two plates. Okay, and this one is another method of joining process. So now tell me, what is the difference in that two?
First one is a permanent and second one is a temporary.
Correct, very good. So the first joining process, if you observe here, this first joining process is permanent joining process. Okay, जी परत आपण रिमूव्ह करू शकत नाही जशीच्या तशी. ओके, जेव्हा पाहिजे तेव्हा काढलं आणि जेव्हा पाहिजे तेव्हा बसवलं, अशी ती जॉइनिंग प्रोसेस नाही आहे. And if you observe second, then we can disassemble this nut and bolt arrangement and easily I can move this plate 3 from plate 2. So this joining is the temporary joining process. Okay. So here in our syllabus, we have only permanent joining processes. Okay. We don't have this temporary joining process. Okay. So in permanent joining, now we will proceed next. So have you understood permanent joining and temporary joining?
Yes, sir.
Yes, sir.
Now we are moving towards the welding process now. So what is the welding? Welding is the process of joining two similar metal pieces by applying pressure on the surfaces in the plastic state or without pressure in the fusion state. So if you observe, if we add heat to the material, it changes structure of the material. Okay, for that one diagram is there in metallurgy. This is part related to metallurgy actually. So one diagram is there, that is iron carbon diagram. Okay, if you put on the Google, you will get that iron that is iron carbon diagram. Okay, so here we get how metal can change the structure. Okay, so structure get changed when we add heat and when we remove the heat. Okay, so melting is one of the point. Melting means, what is mean by melting? So melting is the process or त्याला आपण मराठीमध्ये वितळवणे म्हणतो. Okay, so we call it as fusion state. Melting, it is the fusion state, and before melting there is one more state, that is the plastic state. So welding can be performed by two ways. First is the fusion welding and second is the plastic or pressure welding. Get it up to that? So the fusion welding is the welding process in which we melt the method workpiece and one filler rod. Okay, and then we allow to cool this molten metal, and it will create, after cooling, it will create a joint. So this is one process, that is the fusion welding. Another one is the plastic or pressure welding. So in that we are increasing temperature of the workpiece or that point where we have to join the material. At that point, we increase the temperature up to plastic level of the material. Okay, and then we apply pressure on that. So after cooling, this point get joined. Okay, for plastic or pressure welding, there is no requirement of a filler or filling material. Okay, in fusion welding, in other welding processes, the filler metal is required. Get it? Now this is the welding processes. So first one is the arc welding that we have observed nearby our places. Then second one is the gas welding, or we can call it as oxyacetylene welding, because in most of the gas processes, acetylene, oxygen and acetylene is used. Then these two processes comes under the fusion. fusion welding, and this resistance welding comes under the plastic welding. Okay, these are again come into the fusion welding, but here that not in manual melting, soldering and brazing. Okay, so these are the arc welding, in that gas welding, resistance welding, and the manual metal arc welding. Now this one is the manual metal arc welding. So have you seen this before this? तुम्ही हे बघितलं याच्या अगोदर? ज्या ठिकाणी वेल्डिंगची प्रोसेस केली जाते त्या ठिकाणी एक लाल डब्बा असतो बघा, ट्रान्सफॉर्मर. ओके, त्याच्यामधून एक केबल आलेली असते बाहेर, ज्या केबलला पुढं इलेक्ट्रोड होल्डर पकडलेला असतो, म्हणजे जॉईंट केलेला असतो, त्याच्यामध्ये इलेक्ट्रोड बसवला जातो. दुसरी एक केबल ट्रान्सफॉर्मर मधून घेतली जाते, जी आर्थिंग म्हणून वर्कपीसला कनेक्ट केली जाते. हॅव यू सीन दॅट?
Yes.
Okay.
Yes, sir.
Yeah. So how it works now, see here, this one is the AC or DC supply transformer. Here current can be flow from electrode holder to workpiece and again to transformer, or it can be flow from cable to the workpiece, then electrode and to the transformer. So here is the process. When current flows through that cable and there is a restriction, resistance to that current flow, okay, near workpiece, and here 1.5 to 3 mm gap is required. ज्या वेळेला आपल्याला हे वेल्डिंग करायचं असतं त्यावेळेला तिथं 2 ते 3 मिलीमीटरचा गॅप ठेवावा लागतो. आणि याच्यामधून जे इलेक्ट्रॉन्स फ्लो होतात ते इथं या ठिकाणी मोठ्या प्रमाणामध्ये हीट जनरेट होते. इथे मोठ्या प्रमाणामध्ये हीट जनरेट होते, ज्याच्यामुळं इथलं वर्कपीस जो जॉईंट करायचा आहे तो वर्कपीस आणि हा इलेक्ट्रोड दिसतोय तुम्हाला. दिस वन इज द इलेक्ट्रोड. ओके, आणि हा वर्कपीस, या वर्कपीसचा एवढा भाग आणि हा इलेक्ट्रोड मेल्ट होतात त्या हीटमुळे. आणि त्याच्यावरती हा जर इलेक्ट्रोड तुम्ही पाहिला, इफ यू सी दॅट इलेक्ट्रोड, वन कोटिंग इज प्रोव्हाइडेड ऑन द मेटल. हॅव यू सीन दॅट? त्या इलेक्ट्रोडच्या वरती कोटिंग प्रोव्हाइड केलेलं असतं. ते कोटिंग म्हणजे फ्लक्स आहे. म्हणजे दिवाळीमध्ये कसा फुलबाजा असतो बघा, तारबाजा म्हणतो त्याला आपण, त्याच्यावरती कसं कोटिंग प्रोव्हाइड केलेलं आहे तसं कोटिंग ह्या इलेक्ट्रोड वरती आहे. सो वी कॅन कॉल दिस कोटिंग ॲज अ फ्लक्स. सो व्हॉट इज द फंक्शन ऑफ फ्लक्स? सो फ्लक्स प्रोव्हाइड द gaseous shield like this when welding is going on. So this one is the slag which is made of flux. ज्या वेळेला इथं वेल्डिंग चालू असते, मेटल वितळत असतं, त्यावेळेला त्याच्या भोवती हे जे फ्लक्स आहे हे एक आवरण क्रिएट करतं. सो त्या फ्लक्सच्या आवरणामुळे ऑक्सिडेशन म्हणजे त्या ठिकाणी ऑक्सिजनचा शिरकाव आतमध्ये होत नाही आणि त्या वेल्डिंग मध्ये गॅप्स राहत नाही, म्हणजे सॉलिड वेल्डिंग क्रिएट होतं. After that, this flux is sprayed over this welding or molten metal, and after cooling, that flux can be removed by hammer. तुम्ही बघितले वेल्डिंग झाल्यानंतर त्याच्यावरती एक पापुद्रा येतो.
Yes, sir.
हा, तो जो पापुद्रा आहे तो पापुद्रा म्हणजे तो फ्लक्स आहे किंवा स्लॅग आहे, जे आपण वेल्डिंग कंप्लीट झाल्यानंतर रिमूव्ह करतो. ओके, so this is related to the manual metal arc welding. Okay, now we have some videos. I will see which videos we have. So up to that, you do one thing. You write this heading, manual metal arc welding, and you draw these two diagrams. ओके, हे दोन डायग्राम काढा. तोपर्यंत मी व्हिडिओ चेक करतो. Okay, completed.
No, sir.
Draw these diagrams. You have to draw these diagrams in assignment number 2 also. So for your class test first, you only one chapter is there, that is pump, compressor and turbine. So read this MCQs, all MCQs, and attend the class test. Is anyone having any doubt in before this whatever we have learned? जर कोणाला काही शंका असतील तर विचारा, म्हणजे लेथ मशीन, ड्रिलिंग मशीन याच्या संदर्भात. Now we have 5 joining processes, out of which first one is the manual metal arc welding, second one is the gas welding, third one is the resistance welding. In resistance welding, spot welding is there, then soldering and brazing. झाल्यानंतर सांगा लगेच.
Done, sir.
ओके, बाकीच्यांचं झालं सगळ्यांचं?
Yes, sir.
Okay, 1 second, I will show you video so you will get more idea about this. 1 second, I will open the video. Is this visible? Hello?
Yes, sir.
Yes, sir.
Okay. Now see
Shielded
how
metal arc
welding
welding.
happens. Can you hear
Shielded
the
metal
sound?
arc welding is also referred to as stick welding or manual
Yes.
metal arc welding, in short,
Yes.
MMAW, in which an arc is struck between the flux-coated consumable electrode
So
and
see
the
here,
base metal
this
to
is the
start the welding
electrode holder.
process.
This one is
It
the
is the most
electrode
common
which
type
is
of
coated
welding
with the
process
flux.
seen in any
Here,
job shop
this is
industry.
the work pieces.
Working
So
principle.
two work pieces that we have to join here. Okay. So I will.
This process, the heat required to melt the consumable
Now what is the working
electrode
principle?
form a bond with the base metal is produced by an
Now
electric
this is
arc
the work
struck
piece.
between
This one is the
electrode and
electrode.
workpiece. The shielding for the weld
And
tool is
near
provided by
some
the
gap
flux,
is
some of which
provided
is
here.
deposited on the layer of the
When
weld
heat
in the form of smoke,
develop,
which is
this
removed
electrode
upon
and
heating.
metal get
The choice
melted,
of electrode depends upon the base metal
and
composition.
here we get the
If
joint.
you are new to ADT
So
training,
electrode is made of
click
mostly
on the
carbide
subscribe button
steels,
and turn on
but
all
we can
notifications
change
so
that
you
electrode
never miss
as
an
per the
update.
requirement or as per the
Equipment.
workpiece metal.
Components
But generally
of shielded
carbide
metal arc
steels are
welding.
used as
Power
electrode.
supply. Transformer.
So this one is the
Most common
transformer.
welding
We connect
transformer,
transformer
DC
to the electric
rectifier,
current.
or a DC generator
So
is used.
transformer may be of welding
Electrode
transformer,
holder.
that is DC and AC.
Electrode.
One positive cable from the transformer is connected to the electrode holder, and another cable is from negative terminal to the workpiece with the help of clamp. So here, when we start current, that is direct current electrode positive. This is the one method, and direct current electrode negative. When we connect electrode holder to the positive, this one is connected to negative terminal now, and another cable is connected to the positive. So electron is flowing, or the current is flowing from negative terminal to the holder, then that electrode, and through the workpiece it goes to the transformer.
Upon striking, the kinetic energy of the electrons is converted into heat or thermal energy, thus an immense amount
Okay,
of heat
this
is
is the
generated at the workpiece surface. About
one
67%
arrangement.
of the
So
arc heat
here
is
heat
generated
developed
on the
in
surface
workpiece
of the
near about
workpiece,
66%, and remaining heat is
on the
generated
electrode
with the
surface.
electrode.
This melts the base
So
metal
due
quickly,
to air
thus
gap,
resulting in deeper
the heat
penetration.
intensity
However,
will
the
increase.
deposition rate of the filler metal reduces due to less heat generation at the electrode surface.
So for that, skilled person is required. Actually, how much
polarity configuration,
gap
the
we have to
electrode
keep
is
there.
connected to the
Continuous
positive
gap is
terminal,
required,
and the
otherwise welding will
workpiece
not
is connected
perform.
to the negative
Now this one
terminal.
is the positive
Hence, the
arrangement.
flow of
When
electrons
positive
from the
terminal
workpiece
connected to the
electrode.
electrode,
A major
at that
amount of
time
arc
from
heat is
negative terminal
generated at the
current
surface
is
of the
flowing
electrode,
towards
and
the
less heat is generated at the
workpiece, then
workpiece
electrode,
surface, thus
and
resulting in
again to
high
the
filler
transformer.
deposition rate and insufficient
Now here
flow
heat is
between
generated
workpiece
more
and filler
in
metal.
the electrode.
However,
So
when
electrode
the
melt
electrons flow
fast
from the
here.
workpiece, the dirt and oxide layer is disrupted, also known as arc
But
leading
it gives
action, thus helping in
lower
producing a
strength
quality weld product.
welding as
After setting
compared
the
to the
necessary current and voltage
another type.
parameter, an arc is struck by slightly touching the workpiece with the electrode and carrying forward or backward. Once the arc is struck, the heat generated melts the electrode and base metal, and the filler metal gets deposited on the base metal. The
So this is
electrode
the
should be
simple
held at a lower
way of
angle to the
welding.
workpiece
Some
to
angle
manipulate
should
an arc
provide.
and to
We
carry on
cannot
the welding process. But if the electrode is
keep
held
electrode
perpendicular to the
90 degree
workpiece,
with the
then it is
workpiece.
likely that the tip of the electrode may
Okay,
stick to the
it will
workpiece
melt
and fuse,
more.
causing it to heat up rapidly.
So some angle
Converted into a
required to
shielding
be there
mass surrounding the weld
at the
pool,
time of
protecting
welding
it from
in
oxygen
workpiece
other
and in
atmospheric
electrode.
contaminations. Some of the flux gets settled on the weld puddle in the form of the slag. Once the welding
So
is
that
complete
slag that
and
I
the
have
weld
explained
pump is
in the
cooled down,
diagram,
the slag is
that
chipped off using the chipping hammer
slag is
and cooled
produced,
using a wire
which is
brush.
produced from the
Shielded
flux,
metal arc
which
welding can be used to weld in all positions. That
what
is,
we can say,
flat,
which
horizontal,
can
vertical,
prevent
and
addition of
overhead.
oxygen and all these contaminated particles from the
Advantages.
atmosphere.
The initial cost is low.
What are the
Welding
advantages?
equipment
So
is
the
simple
initial
and
cost
portable.
is low, then
Flexibility of the
simple
process
and
in using
portable,
a wide variety of
flexibility
electrodes.
in using
Electrode
wide
transfer
variety of
coating, which
electrodes,
provides shielding,
then
hence no need for
flux
heavy gas
coated
cylinders or
electrodes provide
shielding
shielding,
gaskets. An efficient and low-cost way of
efficient
joining
and
metals,
low cost.
and good
So the
for
cost
welding
of
in
this
tight
machine is
spaces.
very low. So anyone can start the fabrication. If you have to
A
start the
highly skilled
fabrication
person
work,
is
you need
required
these
to produce a
machineries.
good quality product.
Disadvantages.
Defects
For that,
can be
highly skilled
detected
person is
early.
required.
The process
Hard
is
to
manual
detect
and hence
defect.
high labor.
Then process is manual.
Fumes and
Total
gases
process is
produced
manual
by the
process.
flux are hazardous.
Hazardous fumes and gases are ejected at the time of welding. Okay. Now, what are the
This
applications?
process finds its
There are so many applications
application
of such
in
weldings.
structural welding.
So structural welding,
Shop.
it means different types of structures are there. For example, window structures are there, some grills are there. So these all are the related to the structures. So in that structural welding, we can use that arc welding. Then job shop. Job shop, it means if some jobs are there, that is workpiece, different workpiece in the industry, at that time we can use this. Then shipbuilding, in shipbuilding we can use such type of welding. Then field repair, then marine, and then in aerospace also we can use this welding.
And nuclear. Hope you have understood shielded metal arc welding process. If you like this video, click on the like.
Okay, have you understood this? Yes. का परत एकदा प्ले करू with sound. Hello.
Yes, sir.
Okay, I will increase the sound and you listen.
Button. And want to learn from more such videos, then subscribe to ADTW Learn. Also, you can visit our website, adtwlearn.com, for more such study material. Shielded metal arc welding. Shielded metal arc welding is also referred to as stick welding or manual metal arc welding, in short, MMAW, in which an arc is struck between the flux-coated
Videoचा आवाज ऐकू
consumable
येतोय का?
electrode and the base
Yes,
metal
sir.
to start the welding process. It is the most common type of welding process seen in any job shop industry. Working principle. In this process, the heat required to melt the consumable electrode and form a bond with the base metal is produced by an electric arc struck between the electrode and the workpiece. The shielding for the weld pool is provided by the flux, some of which is deposited on the layer of the weld in the form of slag, which is removed upon cooling. The choice of electrode depends upon the base metal composition. If you are new to ADTW Learn, click on the subscribe button and turn on all notifications so that you never miss an update. Equipment or components of shielded metal arc welding. Power supply. Transformer. Most commonly, welding transformer, a DC rectifier, or a DC generator is used. Electrode holder. Electrode. Ground clamps. Working. First, the power adjustments are made on the transformer. The welding can be carried out by either using direct current electrode positive DCEP or direct current electrode negative DCEN connection.
आवाज ऐकू
DCEN.
येतोय व्हिडिओचा?
In DCEN,
Yes, sir.
the electrode is connected
Okay,
to the
मलाच
negative
ऐकू येईना.
terminal and the
ठीक आहे,
workpiece
ठीक
is
आहे.
connected to the positive terminal. The electrons thus travel from the negative terminal to the positive terminal. That is, from the electrode to the workpiece. Since there is a sufficient potential difference between the electrode and the workpiece, therefore the electrons from the electrode accelerate and strike the workpiece surface at a very high velocity. Upon striking, the kinetic energy of the electrons is converted into heat or thermal energy, thus an immense amount of heat is generated at the workpiece surface. About 66% of the arc heat is generated on the surface of the workpiece, and the rest of the heat is generated at the electrode surface. This melts the base metal quickly, thus resulting in deeper penetration. However, the deposition rate of the filler metal reduces due to less heat generation at the electrode surface. DCEP. In this polarity configuration, the electrode is connected to the positive terminal and the workpiece is connected to the negative terminal. And hence the flow of electrons is from the workpiece to the electrode. A major amount of arc heat is generated at the surface of the electrode and less heat is generated at the workpiece surface, thus resulting in a higher filler deposition rate and insufficient fusion between the workpiece and filler metal. However, when the electrons flow from the workpiece, the dirt and oxide layer is disrupted, also known as arc leaning action, thus helping in producing a quality weld bead. After setting the necessary current and voltage parameter, an arc is struck by slightly touching the workpiece with the electrode and carrying forward or backward. Once the arc is struck, the heat generated melts the electrode and base metal, and the filler metal gets deposited on the base metal. The electrode should be held at a lower angle to the workpiece to initiate an arc and to carry on the welding process, but if the electrode is held perpendicular to the workpiece, then it is likely that the tip of the electrode may stick to the workpiece and fuse, causing it to heat up rapidly. The flux then converted into a shielding gas surrounding the weld pool, protecting it from oxygen and other atmospheric contaminations. Some of the flux gets settled on the weld puddle in the form of the slag. Once the welding is completed and the weld bead is cooled down, the slag is chipped off using the chipping hammer and cleaned using a wire brush. Shielded metal arc welding can be used to weld in all positions. That is, flat, horizontal, vertical, and overhead. Advantages. The initial cost is low. The welding equipment is simple and portable. Flexibility of the process in using a wide variety of electrodes. The electrode is flux-coated, which provides shielding, hence no need for heavy gas cylinders of shielding gases. An efficient and low-cost way of joining metals. And good for welding in tight spaces. Disadvantages. A highly skilled person is required to produce a good quality weld. Defects are hard to detect in the weld. The process is manual and hence high labor cost. Fumes and gases produced by the flux are hazardous. Application. This process finds its application in structural welding, job shop, shipbuilding, field repair, marine, aerospace, and nuclear. Hope you have understood shielded metal arc welding process. If you like this video, click.
Okay, समजलं सगळ्यांना?
Yes, sir.
Metal arc welding.
Sir.
Okay. So with this, today we will stop here, and tomorrow we will see gas welding. Okay, gas welding and resistance welding also. Okay. So thank you all of you. Now put your roll numbers into the chat box. 54, so 60, 62. Is all of you written your roll numbers into the chat box?
Yes, sir.
Yes, sir.
Okay, I will upload that PPTs in teaching diary. MCQ upload केलेत का मी? का MCQ पण करायचं? Okay, I will see what is remaining, then I will upload it. I think all have written roll numbers. So thank you all of you.